Hey everyone, welcome to Spring One. We've had a great couple of great presentations already today. Really excited about this next one. Next up, we have Sam Brannen. This guy is an absolute whiz when it comes to testing with JUnit 5 and with Spring. He's forgotten more about it than we'll probably ever know. So very excited to have him here, ladies and gentlemen. Here he is, Sam Brannen. Hey, Sam.
Hi, thanks for the nice introduction. Let me share my screen here. Okay, so let's get going. The topic today is testing with JUnit 5 and Spring. Talking to you here live from just outside Zurich, Switzerland. My name is Sam Brannen, as he mentioned. First up, the standard disclaimer, in case we talk about anything that hasn't been implemented yet, we may or may not implement it. A little bit about myself to start off with. So I'm a staff software engineer at VMware. I've been a Java developer for over 20 years, so quite a while. And I've been a core committer for the Spring framework since 2007, basically back then when I took over the testing support, and I've maintained that ever since. And that led into my involvement in JUnit. I've been a JUnit 5 core committer since October 2015, since the start of the JUnit 5 project. So on the agenda today, we're going to talk about JUnit 5.7 and 5.8, which is coming out very soon. And we'll be talking about some of the testing features in Spring 5.3.x. And at the end, we'll close with a short discussion on testing within a native image using GraalVM. And then the Q&A session will follow afterwards. So I'd just like to start off by saying that JUnit Jupiter and Spring are actually a great match for testing. In the core Spring framework, we have the Spring extension, which you can use. You can use some of the built-in compose annotations, Spring JUnit config, Spring JUnit web config, to get your tests up and running with Spring and JUnit Jupiter. And on the Spring Boot side, we have the well-known at Spring Boot test annotation and many of the testing slice annotations like webmec test, etc. And those annotations are meta-annotated with @extend with Spring extension. So that means the Spring extensions automatically going to be registered for you. So you're getting the Spring testing support with JUnit Jupiter and Spring Boot out of the box. First up, main topic is JUnit 5.7. It's been out for over almost a year now. And if you want to know the details, you can check out the release notes. I've got a link here that'll give the details on 5.7 GA, as well as 5.7.1 and 5.7.2, which contains some bug fixes. So what happened basically in the 5.7 timeline, for starters, a number of the APIs that we had that were previously experimental, we upgraded them to stable. So that might make some of you happy. We have some various improvements to the engine test kit for testing engines and extensions. We also had some small improvements to the assertions in JUnit Jupiter and some general improvements to the CSV support in parameterized tests when you're using @CSV file source and @CSV source. So if you're interested in knowing what those are, just check out some of the attributes in those annotations and you can see some of the newer features. You might be familiar with @enabled and disabled annotations like @enabled on Jerry for saying, that works on Java 8, Java 9, stuff like that. Basically, if one of those things ended up being disabled, there was a default message that was generated there, the reason for that. And now you can add your own custom reason with the new disabled reason attribute that's been added to all of those annotations. Now, we have actually quite a few major features in 5.7. For starters, we introduced support for Java Flight Recorder. So if you're interested in that, maybe using it in your applications, you also want to use it in tests. Maybe you have some kind of dashboard. The JUnit platform will publish events when tests are executed and things like that. Next up, you might be familiar with the method ordering support we've had around for a while. You could configure that previously with the @test method order annotation on a particular class, test class. And as of JUnit 5.7, there's a new JUnit Jupiter test method order default configuration parameter that you can use to set the default method order for your entire test suite. So for example, you might want to say, for this test run, I would like to have all of the test methods executed in a random order. Now, these next few annotations, some of you might recognize them. They had a previous life before, @enabledIf and @disabledIf. And also don't be confused, there are annotations with the same names in the Spring testing support as well. In Spring, they're based on spell expressions. In JUnit Jupiter, originally they existed for executing conditions based on a script. So for example, JavaScript. But we deprecated that at one point and removed it. And now we've added back a new feature with the annotations with the same name. And this time they're based on what we call condition methods. So you can basically declare one of these annotations and then just point to a local method or a static method in another class. And if that method returns true or false, that will determine whether or not a test is enabled or disabled. So that's a nice addition in 5.7. Next up, if you've been using the parallel execution support in JUnit Jupiter and JUnit Platform, there's a new feature in 5.7 whereby you can annotate a test class with @isolated, and that will basically tell JUnit Jupiter to run that test in isolation. Basically, don't run it at the same time, don't run it concurrently with any other tests in case it's using some kind of global resource. Next up is a small addition for working with parameterized tests. You might be familiar with the @convertWith support there, so you can provide your own converter to have an argument converted when it's injected into a parameterized test. There's a new typed argument converter that basically reduces the boilerplate code and helps you to convert from one specific type to another specific type. And then in 5.8, we've had a few bug fixes for that and a few minor enhancements for that feature as well. That basically covers the main features for 5.7. In JUnit 5.8, you'll see that we have quite a few more, and we're hoping to release JUnit 5.8 in the coming weeks. We've already had JUnit 5.8 RC1 released just last week. So for this, I'd like to break it up between the platform and Jupiter. So the JUnit platform is basically the core, right, of JUnit 5, and it's at version 1.8. And one of the biggest features that I think a lot of people are going to find useful is new support for what we call declarative test suites. So basically, you can just declare a test suite with an @suite class, and then JUnit will then run that for you. So the way this works, there's a new module. It's called the JUnit Platform Suite Engine. And there is a suite test engine in there. It's an implementation of the test engine API. And in addition, we already had the JUnit Platform Suite API module for running suites with the JUnit 4, and I'll show you that in a minute. We have some new annotations for this new feature, namely to start off with this @suite annotation and some other annotations like @configuration parameter, @select URIs, @select file, etc. So basically giving you the full feature set for selecting things and filtering things on the JUnit platform when running with a suite. Next feature is the unique ID tracking listener. This is a JUnit platform test execution listener, and it will basically be registered by default, but you have to supply a particular flag, like a system property, to turn it on, to enable it. And what it does is it tracks the unique IDs of all the tests that were executed, and it will write them out to a file. And then this file can be read in by a build tool or some other tool, for example, to rerun the same tests. And the reason this was actually implemented, this came from a proof of concept that I wrote for the Spring framework itself when I was basically trying to see how we could run tests in the native image. And then I ended up donating this to the GraalVM build tools project, and we'll talk a bit more about that later on. So here we have an example of how things used to be if you're running suites on the JUnit platform. It was kind of a hack, but it was a workaround, and it was necessary originally because originally IDEs and build tools did not know how to run the JUnit platform, but they knew how to run JUnit 4. So what we did when we reintroduced JUnit 5 is we came up with this JUnit platform for JUnit 4. And you can say @run with JUnit platform. That's basically going to use your IDE support for JUnit 4 to run this runner, and this runner will then start the JUnit platform for you and then run a suite. But it had some limitations. Basically, it's an adapter, 2 different worlds. Reporting in JUnit 4 is not the same as it is in JUnit 5. It's not as rich. You don't really have the custom display names like you have in JUnit 5. You don't have things like dynamic tests in JUnit 4. So if you run your tests this way, it will execute the tests, but some of the display names won't be what you want, and some of the dynamic tests and things like that will end up being unrooted tests, so they're kind of just floating in the report and not associated with the class where they're actually defined. So that's just basically running JUnit 4 to run JUnit 5. And now with JUnit 5.8, you just switch that out with this new @suite annotation, and then you continue to use the same annotations you're using before, or some of these new ones I mentioned before, and that will now run using this new suite test engine. So this suite can select classes, it can select packages for class-path scanning to find the tests. It can also select other suites, so you can kind of have like nested suites. That's something you could not do with the JUnit platform runner with JUnit 4. So I think a lot of people will find this quite useful. We do have some small enhancements in JUnit 5.8 as well. Here I have a link to the snapshot release notes, since JUnit 5.8 has not yet been released, but you can check that out if you want to know what's coming. So adding on to what we already had for the Java Flight Recorder, we have more fine-grained events that we're publishing there for things like when things are detected during the discovery phase and things like that. And we also have support for running on Java 8 update 262 or higher when they backported the Java Flight Recorder support back to Java 8. We have a new assert throws exactly assertion, which is an alternative to assert throws. So assert throws has been there since day one, and basically it does an instance of check, whereas when you do assert throws exactly, it's going to execute the code, make sure that it throws an exception that's the exact type that you specified, so a bit more fine-grained there. In addition, we have a new assert instance of assertion, and that's basically what you would now want to use instead of the way you would have done it before. So previously you would have had to say something like assert true object is instance of X. And now with assert instance of, you'll get that support built in for you, and you'll get better error messages if the assertion fails. Last but not least, if you're familiar with @register extension fields, those are now allowed to be private in case you prefer that they're private. Previously, an exception was thrown for that. Now we're going to talk about what's new in JUnit Jupiter 5.8. It's basically the programming model, the way you write tests in JUnit 5. First up, we have test class execution order. There is a new class orderer API that you can implement, and that's analogous to what we had previously for ordering test methods with the method orderer API. Out of the box, we have several built-in implementations, just like for the methods. Instead of the method name, though, we have one for class name. It's going to sort the classes based on their fully qualified class name. So that means including the package name. You can sort them based on their display name, based on the @order annotation, or you can have them randomly sorted, or you can implement your own. I don't have the link for it, but someone out there in the community implemented one that was quite interesting for Spring Boot test suite that he had. I believe he was sorting things based on whether it was like a web test, like a WebMC test, or a regular Spring Boot test, or just a normal JUnit Jupiter test that wasn't using any of the Spring Boot features. And he basically had his unit tests running first and things like that. So you can do quite creative stuff with this API. Now, if you want to configure this, you can configure it globally via the JUnit Jupiter test class order default configuration parameter. So you can set that in the JUnit platform properties file, or you can set it as a configuration parameter, or you can set it as a JVM system property. And one thing I want to point out here is you might want to implement this and register it globally in order to optimize your build. If you're somehow have some kind of list that's tracking how long the tests run, you could do things like run the slower tests first, or if you wanted to, or run the failing tests first, and things like that. So you could basically control the order based on previous runs of your test suite. Another option that's limited to nested test classes is that you can use the @test class order annotation on a class and basically say, these nested tests, I want to run them in a particular order instead of some undefined order. Now, if you don't define the @test class order annotation for the nested class, but you do have a global one, then the global class order will be used also for the nested test classes. So let's take a look at an example here. Here we have @test class order on this top level class, order nested tests. This may have some test methods in it as well. We see has 2 nested test classes, and we're specifying the class order annotation. So we want these nested test classes to be executed in the order defined in the add order annotation. So here we have add order 1 and add order 2, and that guarantees that the primary tests, all of them will be run before the secondary tests. Now this one, we went back and forth on it, the tempter, the behavior, what's the ideal behavior, and due to popular demand from the community, this one was a very discussed, highly discussed, controversial topic and upvoted quite a bit. We did end up changing that. So previously, if you used tempter, it created a single temporary directory per context, like for the test method, for example. And if you had multiple declarations, you got basically a reference to the same one, and people didn't like that very much. So now @tempter can be used to create multiple temporary directories. And now JUnit creates a separate temporary directory each time you have the @tempter annotation. So you could have more than one tempter per test method, for example. Now, if you want to revert to the old behavior, you can do that by setting the JUnit Jupiter tempter scope configuration parameter to per context in lowercase or uppercase, and that will use the old behavior. However, we're not going to maintain that very long. In fact, I think we might even remove it in 5.9. So this is just a temporary solution in case you're relying on old behavior and to give you some time to upgrade to the new behavior. Next up, we have the use of @extend_with on fields and parameters. And this is basically mainly an improvement to the programming model, especially for third parties who are providing annotation-based configuration of their features. So we already had @register extension, and that allows you to register extensions programmatically via fields. For example, if they have like a builder API or something like that. So this is nothing new, but what's new is that we can now use @extend_with on fields as well. And we can also use extend_with on parameters. And this is a declarative approach. So @extend_with just specifies the class of the extension to be registered, whereas @register extension needs an instance of the extension provided by you. So on fields, this extend_with can now be used on either static fields or instance fields. And in terms of parameters, it can be used on parameters in a test class constructor or in a lifecycle method like before each or after each, or in your test method or test factory method, etc. Now you can use @extend_with directly on the field, but that's probably not very likely. More typically, you would define it as a meta annotation, or the third-party project providing the feature would define it as a meta annotation, and you would just use their custom composed annotation. And basically what this does is it really avoids the need to have to declare extend_with for this particular extension at the class or the method, and it kind of hides that implementation detail. And that'll make more sense with an example. So here we have a random number extension, and this comes with an @random annotation. And we see that the target type is field and parameter, and retention is runtime, and it's going to automatically extend with random number extension. So to register that extension for you. And then this random number extension would likely need to implement the before all callback, before each callback, in order to inject fields, static fields, and instance fields. And it would need to implement the parameter resolver to inject random values into your constructors, test methods, etc. And this class doesn't need to be public because the people using this random annotation, they wouldn't need to know about the implementation. So that now just becomes an implementation detail. So here we have an example, random number tests. We can see that we can use @random on a field, and that extension would automatically be registered. It would look up these fields annotated with that, and it would automatically set the value of the field to some random number. And here we have an example with a constructor, an example with a lifecycle method @before each, an example with an @test method here. So each of these would likely get a different random number. But you see this improves the programming experience here, right? So you don't have to see this extend_with, you don't have to know about the implementation details. If your third-party library says just use @random and you get a random number, it's much easier to use. The new named API is basically just a container that associates a name with a given payload. And the meaning of the payload depends on the context in which it's used. Now, there are two ways to create one of these. You can use named.of or named.named. These are both static factory methods. The first would be used if you like that style, if you prefer that style. And the second would be used ideally as a static import. So you would just import the named static factory method, and we'll see that in an example. Now, there are two use cases in JUnit Jupiter where this named API can be used. The first one is with dynamic tests. If you're using dynamic tests.stream, that can now consume named input, and it will use each name value pair as the display name and the value for each generated dynamic test. The next use case is in parameterized tests. So if you're using one of the sources like method source or argument source, the arguments generated by that can also be named, and they can basically supply an explicit name for that argument. So the name will be used as the display name instead of the argument value. So without this, right, the argument value would be used, or the toString would be invoked on the argument value, and maybe that's long, or maybe it's not as descriptive as you'd like to be. And now you can use this named API to come up with custom names for your method source and argument source implementations. So here we have an example. We have an @test factory method that's returning a stream of dynamic tests. And we see in here, we're creating a stream here, a stream of named, where the payload type is string. Now that could be anything. It could be a person object, a number, whatever it is that you need to test against. And then here we're saying stream of, and we're using this named method. So this is the static import for named.named. And the first argument is the name, and the second argument is the payload. So here we have race car as a palindrome, and then race car. And then we have basically various things we want to test on the right, and the custom names on the left. And then to create our dynamic tests, where you can use dynamic test.stream based on this named input stream. And then for each one of those values, right, the payloads, we will get that here, and we can say text goes to assert true is palindrome. So that's the actual test. And then each of these would be the display names in the test tree when you see the results. Last but not least, we have one additional feature for parameterized tests. Now, if you have any arguments that implement JavaUtil auto closable, those will automatically be closed after the test completes. So this allows for automatic cleanup of any resources created for those arguments. Maybe you're closing a file, stopping a server, etc. And in case you've ever written an extension with JUnit Jupiter and worked with the store and the extension context, this concept is similar to the support we have for closable resource there. But for this feature, with parameterized tests for the arguments, we decided to go with the built-in auto-closable API in the JDK. That's it for the overview of what's new in JUnit 5.7 and JUnit 5.8. Now we're going to take a look at some of the testing features recently added in Spring Framework. Here I have a link to the releases. Basically, a number of features went into 5.3 GA proper, but we've also been adding features along the way. So 5.3 to 5.3.9, I'm going to cover those first. See if I can move this off my screen. Okay, so first up, this was a very highly requested feature. The test configuration is now going to be discovered on enclosing classes for your JUnit Jupiter nested test classes. So when we talk about test configuration, we're talking about all the annotations that you're using, like @context configuration, @active profiles, @test property source, @SQL, all of these things. You want them to be inherited, and we'll see an example with that. Another new feature is this application events abstraction, and that basically will capture application events that are published in the application context during the test and allow you to interact with them and perform assertions against those. Next one is a small feature that was requested from the community. So in Spring, we have this spring.test.constructor.autowire mode that you could set via the spring.properties file or a JVM system property. But some users were we're already using the JUnit platform properties file to set other features in JUnit Jupiter or JUnit platform, and they asked if they could have support for this Spring configuration in the same file, and now you can do that. So you can specify the AutoWire constructor mode in the JUnit platform properties file, and we'll look it up there for you. Next one, detection for auto-wired violations in JUnit Jupiter. And what we're talking about here is when you have @AutoWired on methods in your test class, you could have an auto-wired method, just like you can have an auto-wired field or an auto-wired constructor. But what you don't want to do is you don't want to have @AutoWired on your test method, right? Or @AutoWired on a before each method. Because what happens there is that you have two different frameworks look at the same method. And Spring's going to see @AutoWired and think it's a configuration method and invoke it once to auto-wire it. And then JUnit Jupiter is going to come along after that and see it as a before each method or as a test method and invoke it to execute the test. So in other words, these methods would get executed twice, which may or may not work out well for you. And now we have a built-in detection for that. It will throw an exception if you have accidentally done that. Now we have various improvements for file uploads and multi-part support in both mock MVC and the mock REST service server, and various enhancements in our servlet mocks, so for the request and the response. In addition, if you've been using the @SQL support for parsing SQL scripts and executing them, we have some minor improvements there for processing and parsing out the delimiters and the comments. So if you had delimiters inside comments, you might have run into errors, and we fixed that up. That applies not only to tests, but also to anything that's using the SQL script support. So for example, if you have SQL scripts that are executing at the beginning when your application context starts up. So here we have an example, nested tests before 5.3. So here we have dev tests. We've got Spring JUnit config. This could also be Spring boot test. We've got active profiles and transactional, and we want that applied to the tests in the top level, but we also want that applied to the nested test classes. But prior to 5.3, that wasn't possible. So what you see here in bold is we basically had to copy all of the configuration, all the annotations onto each nested test class that we wanted to have the same configuration. So that's pretty ugly, and we'd like to avoid that. Here we see one with some different configuration, but here we had to duplicate that. So now, as of Spring Framework 5.3, the configuration on the enclosing class will automatically be inherited by the nested test classes. But now you might want to have the option to turn that off, and we have an annotation for that. We have @nested test configuration, and you can say for this particular nested test class, please override the config and do not inherit that. So this works for all of the core annotations in the Spring Framework in core Spring. Also works for annotations in Spring Boot and Spring Security, and I believe some of the other Spring portfolio projects as well. So that's a big enhancement. Here we have an example with this application events abstraction. So we see here, if we want to use this, we have our normal config for our test. And then at the class level, we say @record application events. That will turn on this feature. Then we can have the application events auto-wired into our test class. We'll get an instance of that injected. And then within our test, here we have an example. We're invoking the submit order method on the order service, and we're supposing that this should publish an event in Spring's application context. So once that is completed, we can now assert that that has happened. So based on this events, we can stream all events of type order submitted, and then we can check the size, or we can interact with those and assert various elements of that order submitted object. Now, Spring Framework 5.3.10 is coming out in about 2 weeks, and we continue to improve, also in the testing support. So first up, we have a new exception collector testing utility. Basically, you might find this useful if you want to implement something like soft assertions, which you'll see we're going to have in just a minute. Basically, that'll allow you to execute a bunch of different things, collect the exceptions, and then throw an assertion error with all of those combined. So based on that, we now have soft assertion support for mock MVC and web test client. You might be familiar with soft assertions from AssertJ, or you might know the @assertAll assertion from JUnit Jupiter that does something similar. Now, if you've been using HTML unit with mock MVC and you are using HTML file input.setData, what that allows you to do is to basically create the file data in memory instead of referencing a file, and that did not work previously. But now in Spring Framework 5.3.10, that will work with HTML unit and mock MVC. We also have new support for setting the default and character encoding in the mock HTTP servlet response, and that is used behind the scenes in a new feature in mock MVC, which allows you to set the default and character encoding for all of the responses used with that mock MVC instance. So let's take a look at an example here. Mock MVC without soft assertions, the way you would have done it before, or maybe the way you would prefer to do it. Here we have mock MVC perform a GET request saying we accept application JSON, and then we chain together our expectations. So we say first we expect status is okay, and then we expect JSON path name is equal to Jane. Now what could go wrong if the status is not okay, they would throw an exception immediately right there. But what if the name is actually John instead of Jane? Well, if we fix the status or fix the code so that it returns okay, and then we have to run the test again, and then it fails on the next line. So that's something we would like to avoid, and soft assertions help us to avoid that. So let's see how that can be fixed with 5.3.10. Now we have a new method. This is called and_expect_all, and this takes a comma-separated list of our expectations. So here we say status is okay, JSON path name, value Jane. Now each one of these is guaranteed to be executed. If they all throw exceptions, all the exceptions will be collected, and then one single assertion error will be thrown with a summary of all of the failures, and each of the actual exceptions thrown from those will be added as suppressed exceptions into that assertion area. So when you see the error, you can actually find in the stack trace each of the individual exceptions down at the bottom of the suppressed exceptions. Here we have a similar example with the web test client, which has a Fluent API. So web test client get URI exchange, and then we're saying expect status is okay, and expect body converted to a string is equal to hello. And this has the same downside that we had with mock MVC. If the first one fails, then it stops there and does not even attempt to make the other assertions. And now with 5.3.10, we can use the new expect all method, and we see the syntax is maybe not quite as nice as it is with mock MVC, but that's just due to the nature of the API. So again, this is a Fluent API, and we can't break out of it. So we have to have consumers that take access or take an argument of this spec. This is the response spec, and with that, we can invoke the same things we invoked on the previous slide. But again, here, each one of these is guaranteed to be executed. All the exceptions will be collected, and a single assertion error will be thrown at the end. In mock MVC, this new default response character encoding. So here we have mock MVC, we have a web application context being auto-injected into our before each method, and we're using the static factor method to create the mock MVC builder. Now we see this new method, default response character encoding, which takes a char set, so we can set that to UTF-8 and then build it, and that we use as the default response encoding if one is not supplied by your controller, for example. And then we can just use mock MVC as we normally would. So that's it for Spring. Now I'm going to talk a bit about GraalVM native build tools, especially focusing on testing. Hopefully some of you saw the talk earlier today by Sebastian, where he went into great detail about the Spring native efforts there and how much progress the team is making there. He also showed some examples with the testing support. And if we have any questions in the Q&A session, I could go into that in more detail, or I can also show some other examples or just answer any other questions. So straight from the homepage, the Native Build Tools project provides plugins for different build tools to add support for building and testing native applications written in Java or any other language compiled to the JVM bytecode. This is grown out of a collaboration between the GraalVM team and the Spring team, and recently the Micronaut team has joined as well. So the build 2 supported currently, there is a Gradle plugin and a Maven plugin, and there's support for compiling your native images, right? Compiling your Java application into a native image, and also testing within a native image using the JUnit platform specifically. So the focus there is really the JUnit platform at its core. That means basically any test engine for the JUnit platform should, in theory, work when running within a native image. We have some support for JUnit 4 and specifically for JUnit Jupiter, but you could try something else out like JQuick. That should work in theory as well. Also, the new TestNG engine, you may or may not have heard of that. There's now a TestNG engine that Mark Phillip has written that allows you to run TestNG tests on the JUnit platform. So in theory, you could also run your TestNG tests inside a native image. And if you do try that out, please let us know. We'd love to know how that goes. So why would we even want to test within a native image? Java is write once, run anywhere, right? We've known that for years. But a native image is not your app running on the JVM. So even though you wrote it in Java and compiled to bytecode within your native image, it's not the same. So you really need to test inside the image. Then you might be thinking, well, we've already got our test suite, right, on the JVM. We could just rely on the normal JVM-based test suite because the app is already tested, right? But you haven't tested it inside the native image. So you really need to make sure things are working inside the native image because things are different. So another thing people might say is, well, you could test your native app from the outside, for example, via HTTP endpoints, kind of like black box testing. But do you really have HTTP endpoints for every feature of your app? And the answer is probably not. Now, I know there are some other frameworks out there that go with this approach, but we really advocate that you write your tests and have them executed inside the native image alongside your code and not just testing from the outside. Especially if you have things like framework code that doesn't have any kind of external endpoint that can be connected to. So as a best practice, what you should do if you're moving to the native image world, or if you're starting out using native images, you should continue to write your tests like you normally do for the JVM, run them in your IDE, run them in your build, but you should also run the same tests or potentially a subset of those tests within an actual native image with your application compiled into the native image so that you have the real assurance that your code is doing what it's supposed to do, not only when running as Java, but also when running as a native image. So how can one of the plugins from the Native Build Tools project help you out in this regard? Well, the plugin is going to first run your tests in the JVM using this unique ID tracking listener that I talked about. And again, that's going to track all the tests that you want to run later in the native image. And the reason this is necessary is that, again, a native image is not Java. There's no class path in the native image, so you can't perform any kind of class path scanning. And that's what JUnit does, right? So it scans the class path to find out your classes that have @test methods. And since it can't do that, we run the tests first in the JVM, we track which ones we ran, and then we run them again inside the native image. Now, you might run into cases where the code, your tests themselves, or the code you're testing requires reflection or uses resource bundles or other things like that that requires configuration for the native image compilation. And if that's the case, you're going to need to run your JVM tests with the GraalVM agent. That works with the Gradle support. Currently does not work with the Maven support, but there's an open issue to have that addressed later in the build tools. So the plugin is going to compile your app and your test into a single native image using the JUnit platform feature, which is a GraalVM concept of this feature that does certain things as the image is being built. And then the plugin is going to run your tests within the native image using the using the native image JUnit launcher. So that's basically the main class inside your test native image. It's going to start the JUnit platform, and it's going to select all your tests for you based on the output of that unique ID tracking listener. So that's how it all works as a big picture. Then when it's done, the outputs will be, the results will be written out to the console and also to XML test reports using the de facto standard ANT-based JUnit 4 XML reports. That means that the XML reports can be parsed by your CI build and displayed visually. Now, how can you actually use the native build tools? Well, if you want to do it on your own, you can follow the instructions for configuring your Gradle build or your Maven build by going to the native build tools documentation. Another option, especially or much easier if you're a Spring developer, go to start.spring.io and make sure you select the native support there, Spring Native, and then start.spring.io. When you download your Gradle build or your Maven build script, it will automatically be pre-configured with the native build tools support and setting up the testing and all of that. Now, once you've done that, in Gradle, you can execute Gradle native test for the standard approach. And if you need the agent, you would want to run Gradle-p agent test to run the tests once with the agent turned on, the GraalVM agent, so that it can track what kind of reflection it needs and stuff like that and generate the configuration for you. And then you would want to run Gradle-p agent native test to tell the native test plugin to use the output from the agent when it's building your native image for the tests. And in Maven, you would run Maven-d skip. That part is going to say, or tell the native build tools, do not build the application native image right now. Just build the test one. And using the -p native is going to switch on the profile that's pre-configured for you, again, with start.spring.io, or which you can configure yourself based on the recommendations and the examples in the native build tools documentation. So some things to keep in mind if you are going this route, if you're starting to work with native images and want to test them. First up, covering some of the same things that Sebastian covered earlier in his talk. Not everything works in a native image or the way you think it would. As I mentioned before, class path scanning doesn't work. Dynamic class creation doesn't work. So stuff like cglib, and that means that certain things like Mockito and various mocking libraries simply don't work at the moment within a native image. So you might have to switch from using class-based proxies to dynamic proxies and running with the agent, and you might be able to get pretty far with Mockito. I know with Mockito there's a new mode you can switch on to use dynamic proxies instead of class-based ones. So that might be an option if you have interfaces that can be mocked. But there are other things that that might not work as well. So you need to really run the tests, see what's wrong, and then come up with a solution. So one solution could be to exclude certain tests within the native image. So I mentioned before, you want to keep writing all of your normal tests and to potentially run a subset of your tests within the native image. So one way to do that is to define custom tags in JUnit Jupiter with the tag annotation. And when you're running your test native image, you could basically disable those tests. Another idea would be to implement a custom execution condition in JUnit Jupiter that will determine if you're running in a native image and whether or not things should be executed within the native image or not, or even built into it. Now, if anyone has any questions or wants some examples on some of those, I do have some tags and some execution conditions that I had written for the proof of concept that I wrote for the Spring framework. It's nothing official, but it's something I could share with you if you're interested. And last but not least, building a native image can take quite a long time. So maybe your build takes 3 minutes normally, and maybe your native image build takes 10 minutes or 15 minutes or 30 minutes, who knows? It could take quite a long time. That does improve over time as GraalVM gets better and the compilation gets faster, but it is something to keep in mind, and it's probably not something that you want to do multiple times a day, definitely not hundreds of times a day. And so you might want to have a dedicated CI pipeline to run your native image tests, maybe in a nightly build or something like that. So I've gone through the main points I wanted to cover. Now I'm going to switch and show at least a demo. I think I have some time here. Let's see. So I wanted to show one with the suite support. This is a test suite that I have in the Spring framework that I use to run the JUnit Jupiter tests when I want to run them all together. And if I just execute that, it says no test run with JUnit 5. I need to switch that to JUnit 4 because again, this is run with the JUnit 4 and the JUnit platform runner. Now we see that's running, quite a few tests. And what I mentioned before, if I can move this. Here we see the test class at the top. And then we see JUnit Jupiter underneath there because that's the engine we selected. And then we see all of the tests, but it's not using the nice display names. It's using the fully qualified class names. But then once you're in there, you can see that it should work. If I double click on that, it should go straight to the method. So that does actually work. But what we also see is unrooted tests. And these are all of the dynamic tests and things like that that just don't work with JUnit for running the JUnit platform. And if you were to click on one of these, you usually get an error in your ID because it doesn't even know where that test method exists. But it may jump to the class or it may not, depending on which one you clicked on. So that's not a really nice option, right? It runs the test, but it's not the way you'd like, and the display names aren't really what you were hoping for. So now if we switch that out, what I've done here is in the build, I've switched to 5.8 snapshots, and I added in the, so I can find it, JUnit Jupiter, the platform suite engine. So that's going to give me this new suite engine that I can use. And now I can comment this out. Don't use JUnit 4, use the new suite engine, hit that. And now when I run, it's probably going to say an error because it thinks it's JUnit 4. That's right, but I can switch in Eclipse and say use JUnit 5. And now if I run it, you see that it's much nicer. So it's not the fully qualified class name, it's the actual name of the class. Underneath that, you have the various engines. So here we have JUnit Jupiter to start with, and now we don't see any of these unrooted tests anymore. So if we look through them all, we see some of them probably even have custom display names like this one. It's got a space in and an @sign, and we have Spring beans injected. And now if we click on one, it will actually jump straight to the method. So this means that everything is working the way you'd expect it to, with custom display names, with JUnit Jupiter, and everything works quite nicely. You could also add a custom name if you wanted to. We could say something like suite display name, and we could say JUnit Jupiter test. If I can type, there we go, and run it again, and we'll see they should have the custom name. If it would, I guess I can switch off auto scroll. Yeah, there we go. So custom display names across the board. So that's a much nicer feature. Let's see what else we got. Oops, not that one. The extension. All right. I think I'll hold that off to the Q&A and see if there are any other questions we can switch in. All right. I think I'm going to conclude it there. And we'll go to the Q&A. So thank you for coming to Spring and JUnit and a bit on GraalVM testing. If you want to contact me on Twitter, I'm Sam_Brannen. The Slack session, hopefully you're already connected and hooked up in there. If not, it's session testing with JUnit 5 Spring and native images. And the Q&A link should show up in there pretty soon.
Thank you very much, Sam Brannen, ladies and gentlemen. Testing with JUnit 5 and Spring. Just a reminder for all of you, if you have any more questions for Sam, and I'm sure some of you do, be sure to click the Zoom link, which is in your Slack for this particular presentation. He's standing by right now for a Q&A session to answer any and hopefully all questions that you may have. So listen, I'm inviting you to stick with us. Coming up in just a few minutes, we're going to talk to Glenn Renfro. He's got a great presentation about application modernization and migrating mainframe apps to the cloud using Spring. That's a mouthful. So that's coming up in just a few minutes. Please stick with us. Don't go anywhere.